In this episode, we start by turning a confusing idea into something you can picture and explain. How payment data moves from the moment a customer enters it to the moment the business gets an approval or a decline. New learners often know that card data goes somewhere, but they cannot describe the path, the handoffs, or the places where data can accidentally be copied and exposed. Mapping data flows is the skill that fixes that, because it forces you to describe the journey step by step and to identify every system, person, and connection involved. Once you can map an end-to-end flow clearly, you can answer practical questions like where the cardholder data environment, CDE, begins and ends, which systems are in scope, where encryption must apply, and what evidence proves that controls actually protect the path. It is also a confidence booster because many PCI questions become easier when you can mentally trace the flow and see what the question is really testing. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good first step is defining what a data flow map is in plain language, because people sometimes imagine it as an artistic diagram rather than a security tool. A data flow map is a representation of how information moves between components, including where it is collected, where it is processed, where it is stored, and where it leaves your environment. For PCI work, the focus is specifically on cardholder data, and especially the primary account number, PAN, but a flow map also pays attention to related information that might travel alongside it. The map should show both the direction of movement and the boundaries, such as when data crosses from a merchant system to a service provider system. It should also show the interfaces used for movement, such as web forms, application calls, internal network connections, and any external connections to payment processors. When you treat the map as a security story of how data travels, you stop thinking in abstract terms and start thinking in concrete paths that can be protected or abused. To make this approachable, it helps to think of an end-to-end payment flow as having a few common phases that show up in most environments, even if the technology differs. There is an entry phase where the customer presents card data, like typing it into a checkout page or handing a card to a cashier. There is a capture and handling phase where a system receives that data and prepares it for authorization, which could involve a point-of-sale application or an e-commerce backend. Then there is an authorization phase where data is sent to a payment processor or gateway and a response is returned, which is usually the moment a transaction is approved or declined. After that, there is a recording phase where the business stores what it needs for receipts, accounting, refunds, disputes, and reconciliation. Finally, there is often a reporting and support phase where data influences downstream systems like customer service, analytics, and fraud review. Your job in mapping is not to memorize a universal flow, but to identify how these phases appear in the environment you are describing and where card data actually travels within them. One of the most important beginner insights is that data flow mapping is not just about the primary payment application, because supporting systems often touch the flow in subtle ways. For example, a web server might route requests to an application server, and load balancers and reverse proxies might be part of the path. Logging and monitoring systems might ingest transaction details or error messages, and those systems can become unexpected storage locations. Identity services might control administrative access to the systems in the flow, and that affects the security of the path, even if identity systems never see the PAN directly. Backup systems may capture the databases or file stores that contain transaction records, which means they inherit the data flow's sensitivity. When you map, you want to include these supporting components so you can account for how an attacker might reach the flow and how data might be copied into places you did not intend. A clear map acknowledges that a payment flow is an ecosystem, not a single line. A useful way to structure a map in your mind is to always start with the question, where does the PAN first appear in our environment? Because that point often defines the first scope boundary. If the organization uses a hosted payment page where the card details go directly from the customer's browser to a payment provider, the PAN might never touch the merchant's servers. If the organization captures card data on its own systems before sending it to a gateway, The PAN enters the merchant environment earlier and drives a larger CDE. These two situations can feel similar to a customer, but they are very different for PCI scope and risk. Mapping forces you to distinguish them based on actual data movement rather than assumptions. Once you identify the first contact point, you can trace each handoff and ask whether the PAN is present in full, in masked form, or not present at all. As you trace a flow, you should pay attention to how data is transformed, because transformations can reduce risk or create new risk depending on how they are done. Tokenization is a common example where a sensitive value is replaced with a token, and if it is done correctly, the token can be used for business purposes without exposing the original card number. Truncation is another transformation where only part of the card number is retained, which can reduce sensitivity when full numbers are not needed. Encryption is a transformation in the sense that data becomes unreadable without keys, and it matters both in transit and at rest. The map should reflect where these transformations happen, because that changes which systems are in scope and what controls must be validated. Beginners sometimes assume that saying tokenization or encryption solves everything, but mapping shows whether those steps happen early enough and whether any copies of the original data still exist. A strong map makes transformations visible so you can reason about their impact. Another critical mapping habit is marking boundaries and trust zones, because security depends on where you trust data to travel and where you do not. A boundary might be the edge of the merchant network, the point where traffic goes to a third-party gateway, or the separation between an in-scope segment and a general corporate network. Trust zones are areas where systems share a similar security posture and where access is controlled in a defined way, such as a tightly controlled CDE zone versus a less controlled office network. When you map, you want to show when data crosses these boundaries, because that is where controls like encryption, authentication, and monitoring become most important. Boundaries are also where misunderstandings happen, such as when teams assume a provider is handling protection while the provider assumes the merchant is. A clear map makes the handoff explicit so responsibilities can be assigned and verified. It is also important to map not only the normal successful flow, but the common alternative flows, because real systems do not always behave ideally. Payment declines, timeouts, retries, and partial failures can cause systems to log extra details or store temporary data for troubleshooting. Refunds and chargebacks can trigger different systems and different data movement than the original purchase. Offline transaction modes in point-of-sale environments can create local storage that later syncs, changing where data exists over time. Customer support processes can lead to screenshots, notes, or ticket attachments that contain sensitive fields if people are not trained. Beginners often map the happy path and stop, but security issues often live in exceptions and workarounds. Including alternative flows does not mean drowning in detail. It means acknowledging the few common deviations that create the most risk. A high-value mapping skill is being able to explain the difference between data flow diagrams and system architecture diagrams, because they can look similar but serve different purposes. A system architecture diagram focuses on components and how they are connected in a general sense, like servers, networks, and services. A data flow diagram focuses on the movement of information, including what data is moving, when it moves, and what changes happen to it along the way. For PCI work, you care about where the PAN travels, whether it is encrypted, where it might be stored, and who can access the systems that handle it. Architecture alone can hide these details, because it may show a connection without showing what moves across it. Mapping data flows makes information movement the center of the story, which is why it is so useful for scoping and control validation. When you can speak this difference clearly, you are less likely to produce diagrams that look nice but fail to support security decisions. As you build and refine a data flow map, you should also learn to identify the typical places where maps become inaccurate, because those inaccuracies create surprise risk. One common problem is missing an integration, such as a marketing or analytics script that captures form fields in an e-commerce checkout flow. Another problem is ignoring administrative paths, like remote support tools that can access payment systems and therefore can impact the CDE. A third problem is forgetting downstream data stores, like reporting databases or file exports used by finance teams. Maps also become stale when systems change, which can happen quietly through software updates, vendor changes, or new business requirements. The habit you want is to treat a map as something you revisit and confirm, not something you draw once and then forget. In exam thinking, this translates into always questioning whether the described flow includes all relevant components and whether any exceptions could change the answer. Finally, mapping is valuable because it helps you connect PCI roles and responsibilities to real technical and business handoffs. When data crosses into a service provider, you need to know what the provider receives, what they store, what they return, and what proof exists that they protect the data appropriately. When data remains inside the merchant environment, you need to know which teams own the systems and which controls must be applied and monitored. A clear map becomes a shared language that lets business people, developers, and security learners agree on what is happening. It also becomes a foundation for later decisions like segmentation validation, scope reduction techniques, and encryption requirements. When you can explain a flow end to end without hand-waving, you can answer many exam questions by simply tracing the path and applying control intent at each step. By the end of this lesson, the big takeaway is that clear data flow mapping turns payment security from a foggy topic into a traceable system you can reason about. You start at the moment the PAN appears. You trace each handoff. You make transformations like tokenization, truncation, and encryption visible, and you mark boundaries where responsibilities and protections must be explicit. You also account for common exceptions like failures, refunds, and support processes, because those are where data often leaks. Once you can do this, scope decisions become defensible, control requirements become easier to place, and exam questions become less intimidating because you can visualize the flow instead of guessing. The better you get at mapping, the more confident you become that you understand not just the words of PCI, but the real-world movement of the data PCI is trying to protect.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.